Mic off. No. Does it work with the mic on?
It's off. Well, there you are. All right.
Testing 1, 2, 3. This is the sound check. This is the best part. This is the only part of the meeting where we're focused on a particular goal.
Testing 1, 2, 3.
We're back to the conspiracy theories again. The microphone is on when you're in the bathroom, and it might be in range this week because we're using a different bathroom. I can just imagine the next court case where they're showing one of our old YouTube videos.
You are streaming now.
I know I'm streaming now. That's why I'm blathering, just to have some stuff there, and maybe someday there'll be somebody that will. Would you like to volunteer? I heard him ask.
That'll be the last time you try that.
Seriously, if you want to say, it could be better if you did this, that, or the other thing, that in this group, that is the same as volunteering to do it better.
Because we are all lazy. Well, we're experimental.
I mean, they're so long. It's kind of intimidating to some random person wanting to look into what SVFIG is all about, and then see just all that space.
Awesome.
You know what's great is I start up YouTube, and the thing that's on the top of the YouTube page is the fourth meeting and live chat.
Oh, we're live chatting right now?
Say again?
Are we live chatting right now?
There is live chat available on YouTube right now.
You can chat with me if you'd like.
Is there anyone not in this room that's chatting with us?
Can we do it without actually? No, there is.
So every once in a while, somebody types something and he doesn't get any response because we're not paying any attention to it, but that's the way life is.
Every so often I go back and look at them because I get notifications if somebody chatted at me. But about once a month. So next month I'll respond to the chats today.
All right. This is your 3-minute warning. If you want to pee, you do just barely enough time.
Remember, second floor bathroom.
I'd recommend it.
It's the better bathroom.
The crazies out there.
They're not crazy, they're just younger than me.
So this pertains only to people that are in the room. There's a bunch of books and stuff. JFAR is in the back of the room. Some other stuff that I just threw in the trunk of my car because I wanted to go through it, because if it's something really valuable, I don't want one of you ne'er-do-wells wandering off with it and then throwing it in the trash, much as I will be doing in a couple of years when. But if it doesn't spring joy in your heart, don't pick it up and take it home. I think that's what my wife has tried to communicate to me. That is a perversion of Marie Kondo, yeah. I was going to say that and thought better of it. They seem so full of energy and excitement. And
It reminded me of South Park, the production. Some guy yelled out one of the quarter's second slogan, shout out a slogan, and the students responded didn't repeat it. They had some rejoinder. So they've had training, or now they're going out and doing.
What you're saying is there's a script.
I'm saying, what is the prime directive? Thank you.
In 10 years, you gotta donate back to Sanford.
No. See, just like the new education system, if you get money, right, and they help you through schooling, they get a percentage of your income for the rest of your life.
That's a different deal that you have to sign up in advance. At some one particular school has started doing this,
It seems to be covered everywhere.
where they get a percentage of your salary.
Oh, those are for boot camps, right? For the
No, this is
This is a university.
for basically enslaving people to your standard
Contracting with.
right. What do they call that? Working for the company store.
Indebted servitude, I think, is
Yeah.
the
Pretty much.
indentured servitude.
They call it indentured servitude. Indentured, yes. They're just words. What
Yes.
the hell time is it? It's time for rumors and gossip.
It's 15 seconds away from the start of the meeting, but first I have to stand here and say thank you. Thank you. For those of you who are out there on the interwebs, there was applause from another group having another activity elsewhere in the building. But welcome to the March meeting of the Silicon Valley Fourth Interest Group. And all that stuff that went before, that if we were editing, that's where we'd edit. So once again, welcome to those of you that are here and those of you that are joining us on the internet, either live or tape delay. Yes, it's another.
On your screen in 3 seconds. 2, 1, 0. Whoa, you're late. What? It's not scanning for.
Oh, I didn't think it did that. All right. Yes. This is Windows of a slightly older version, and it does things like updates. But for a long time, it refused to do updates. It had some kind of problem, and then magically, I think it was earlier this year, it just started working. It was the damnedest thing. So the 14 o'clock, the 2 o'clock talk of Don Golding will not be presented today because Don is sick, but maybe Ting will take a few minutes and tell us a little bit of what Don would have presented were he here. And he's not paying attention, so good. What else? We're starting early just to annoy people. That's good. It's always nice to have those adjustments to the schedule. And George, why don't you conduct introductions, rumors, gossip, announcements? But first, I want to say I'm Kevin Appert. I'm the chairman of the program. The program chairman. No, it's chairman, and that's gender neutral, I'll have you know. It is good for persons of either sex. And just remember, persons have sex, pronouns have gender. But I digress. Yes, okay, the LSI 1123, I think, was the last computer I really understood. If you put that to yourself, and as people talk, I recommend you walk up to them so that they can hear on the third of the interwebs.
You can. It's so. I really like those voting machines that were mechanical, that the innards of the voting machines were not a trade secret. When a fundamental principle pervades utterly a republic, it compromises the integrity of that republic. You can look for THERAC-25 or radiation medical devices, software failure deaths, or you can just ask for THERAC-25. At the time that articles were written, it was the biggest software goof, resulting in death. Now we don't know what happened to those two planes. But the shape of things to come shows us what autonomous airplanes are when they are built by corner-cutting, floor-flushing, free market rather than humane. And how can you make a humane market? We have only a half an hour for this. So Star Trek, nobody pays for anything, you just go get things. We can't have that but we can have the cheap knockoff of this with the new mom and pop shop electronic wallet charging system, so that you can go to your 5 and dime around the corner, pick up things, and not have to pay for them with handing over money. And if you want to buy things anonymously, what's wrong with you? I saw Bach advertised in the Google recently, and it reminded me of Gödel, Escher, and Bach and Escher's Metamorphosis mural, 10 feet of mural, reminds me of how what we say about what we want changes depending on how things are turning out. And I didn't say any of that if it contradicts anything to come. Public service announcement. Princess Leia's stolen Death Star plans. Okay, there's a thing called Princess Leia's stolen Death Star plans. Who bears an introduction? Who would share some rumor or gossip? Yes, I shan't prey upon you.
All right,
yeah, I had a 1-minute rant about Boeing. But
you touched on it briefly. You want to take Mike?
no, he said the Star Trek thing was mine, and in a sense, yes.
Okay. So what is it? Stolen Death Star plans? Is that on the interwebs?
Well, see, if it's a thing because internet knows.
Oh, is that our definition now for what a thing is?
Where would you go?
All right. So those of you who read the, I don't know, meeting announcement or the email or any of that stuff know that the next thing is new things. Occasionally Dave does a nice presentation, for which I'm grateful. Dave is busy right now. So we're going to have to do it ourselves, exclusive of Dave's activity. So John, what new piece of technology have you been exposed to? Is there something that you've seen like in the last month or two that you said, hey, that's pretty cool and that's new?
Yeah, let's see.
Think about it and we'll get back to you.
Okay, I will think about it.
All right, I could smell that smoke starting and I was wondering what that was. How many of you have a file server of some sort? Brad, okay, Brad's got his hand up, what a relief. How many of you have one in your pocket? This is a USB memory stick. Dave's got his hand up. Wow, cool. This is a USB memory stick that has built into it Wi-Fi. And there are apps for your phone, and there are apps for your Android or iPhone. And I guess you can also look at files on this thing with a web client, a browser, as we used to call them, and also just copy to and from this thing without sticking it in the USB. But if you want to do it that way, there's a USB on it as well. I guess you have to charge it somehow. It's got an off-on switch, so you won't be able to see it right now. This one's by SanDisk. There may or may not be others. The Silicon Valley Fourth Interest Group does not endorse any particular manufacturer, but I bet you in 30 seconds with a web browser you can find that one. Does anybody else have any piece of new interesting technology that they saw in the last month? Dave does. All right, Dave, the master of new things.
Okay. This is both technology and things that might benefit a person with a disability. So this is an app that I saw that runs on Android that will literally recognize your speech in real time and print it out. So if you're a person who is deaf, you can engage in a conversation. So I was exposed to this about a month ago. The student brought this out, started talking, and everything he said appeared on the screen absolutely correctly. And then I responded to him. Everything that I said was on the screen. So it's absolutely amazing because given the state of speech recognition as I knew it, I would have thought that having 100% correct recognition would be near impossible. I think it's called AVA, but I'm checking it.
Amazon's got it very good. They're probably either that or something.
There's I've seen at least one other one that does the same thing, but there's been people working on having it all self-contained in the device rather than be in the cloud.
Yeah, that sounds very good.
That's it. That's it.
Okay.
Forgive me. Remember when computers were gigantic and there would be only 8 or 9 supercomputers in the world, and then we all had computers, and now the computer store is now a cell phone store and the cloud, and it's like the Terminator guy when you put the liquid gas on him, he breaks into a zillion pieces. But there is something about our species and technology such that giant things, it enables giant things. Speech recognition, until I get it on my computer, if you have nothing to, why am I even saying that out loud?
One of the biggest drivers for the development of speech recognition technology has been certain, we used to call them TLA, three-letter agency. Certain three-letter agencies desire to be able to take in huge amounts of audio data and without having a person sitting there full-time listening to everything, find little pieces that they are interested in. But we digress.
Yes, we do, and don't hold us back.
Where did you get your device?
I believe I bought this one from Amazon.
Oh, okay. Thank you.
But that's much less than I paid. That price may not be right.
It may be coming down quickly
Well,
if they have too many of them in stock.
I'm amazed. This is shopsandisk.com, and I wouldn't vouch for that price being correct because it seems way too low. What?
Western Digital is
Yeah, they still use the brand name though.
yeah, everybody does.
All right. I have in my house a fluorescent fixture. It's sort of over the sink. It's sort of, I don't know if the ballast is getting iffy or it's just that some days it's cold up there in that space that it's in or what the deal is, but it has for some time now not worked very well. You know, you'd flip the switch and it wouldn't light at all or it'd flicker or some damn thing. I was in Home Depot, another brand that we don't endorse, and looking for a new fluorescent tube, a couple of tubes to throw in there, thinking, oh, you know, I'll throw in a couple of new tubes, maybe it'll work better, because sometimes that helps. Not that there's anything wrong with the old tubes, They're perfectly good. They haven't really been up there that long, but sometimes throwing a couple of new ones in works better. Not well, mind you, but better. I saw at Home Depot a reasonably priced make-believe fluorescent tube with LEDs that are sort of white. If you're picky about the color of your light, this isn't for you. LED lights in general, a nice, cool. There's some really cold, very white fluorescent tubes that I like. And damn it, it really annoys people in my kitchen because it's too bright. Different people have different desires for their lighting, but we digress.
LEDs, structured non-dimmable. So it's not it's like a non-dimmable fluorescent.
Well, the thing about this, the most important point that I'd like to make about this is that it is completely plug and play. Now, they say on the box that you should look up your ballast and make sure that it's compatible with the bulb and da-da-da-da-da-da. I recommend if you're going to do this, buy it at some place that'll take it back if it doesn't work. Pretty much any ballast that it'll work with, you'll plug it in, it'll work, and you'll be done. Most ballasts, especially older ones. If you've got a newer one, why the hell did you buy a new one? But we digress. Off on a tangent. Anyway, this plugs in right where the fluorescent tube was. You don't have to do anything except buy it at a relatively reasonable price. Depends where you buy it. Buy it at beyond the scope of this talk. Buy it at a relatively reasonable price, take it home, plug it in, run away. You're done. And it worked. It lit up. And it was reasonably bright. And it was...
The downside is small, usually non-fatal. But to say, we're going to drop this cockpit, you've done this cockpit, it's hardly a new plane at all. It's an upgrade of the plane. It's a better plane. And it's going to act just like the old plane, because we put adaptive software into it. So if you have the right ballast and you're trained on, by the way, things can go south. So this sort of recapitulation of things great and small and the shape of things to come, it's like it's under our skin. If we don't become aware of ourselves in time, we will be imprisoned by our production, the fruits thereof.
I suspect you are.
I've had the same problem with my fluorescent bulb in my kitchen. And it turns out that it's temperature related. When the temperature in the last few weeks has gotten a little bit warmer in my house, it works. But
yeah, I'm introducing this concept too late for many of you. Now that winter is officially over, you heard that sound. That was boing off in the distance. That was spring. All right, John, did you think of anything new and exciting? All right.
Oh, only thing is, Ting saved my bacon, I think. His, let's see, his thing where it says cold, then abort, then quit, then query, then evaluate. If everything went well, then you go back up to abort. No, not right. No. If you didn't have any errors, you went back to quit. So I think I wrote the fourth of that as an infinite loop, which then I can be able to implement as a P thread so that I can have an interactive thread running at high priority. That might do it. Oh God, if it does.
just be careful if you start the whole.
Yeah, well, I don't know. That's okay because it will work thread.
Make sure that
The important system, yeah.
In our discussion of new and exciting technology, I came across a Google Doodle a couple of days ago. It was on, was it Bach's birthday? Anyway, I recommend you go to the Google Doodle archives and have a little fun with this. You type in a melody, you type in the top line, a little bit of music. You can type in notes at random. It doesn't really matter. And the AI associated with this Google Doodle will generate harmony. And it sounds amazing. It's not quite Bach, but it will do. I was very impressed. Even to my untutored ear, you can decide for yourself. If you go to the article, it is linked from the Google Doodle about the making of this thing. I think they have a making of video. So if you're interested in that stuff, have a look at the making of and read about the trails and travails thereof. And I think they've got like a list of all the people that worked on this thing and all of that stuff. Brad, you had your hand sort of half raised. You don't have anything new and exciting to tell us about?
I have a little thing that's not. I can do a little mini thing.
Now's a good time. All right. Well, he's making his way to the front of the room.
While you're making way, finding something on Google, Robert Mueller's report. Robert Mueller's day off.
Mueller.
What?
Mueller. All right. So, which video?
From who brought you well, it's like the mother of all cliches. You see, to speak its name is to speak the cliche. So that made it hilarious when people were murdering, warring against each other in Iraq. I lightened the joy by coining the mother of all cliches. Similarly, it's informative saying Robert Mueller's day off because he's taking the rest of it off now. Sorry.
Spring break.
Those LEDs actually white, or they actually?
How's it coming? Please, will you start talking into this?
Which, I don't know, is it on? Are we on? Are we on? Can you hear me now? All right. Well, this will hopefully be sort of short. I can tell you about the mad ravings that wander through my mind during a month. So a thing I've been puttering on in the background is thinking about letters and fonts as I've done in the past. And some of you may recall many years back, I tried to produce a very small font using Bezier curves and whatnot. And sort of where my head went was, well, thinking about, if I were to make a very simplistic sort of box-shaped font out of just rectangles, what kinds of nice things could I do with that? And but of course, craving minimalism of an extreme sort, I got to thinking, well, do you really need all the letters really like that? Maybe I can shave down which letters I want to use, and if I was going to go for fewer than 26 letters, perhaps I should go for a nice round number, 16, let's say. So I asked myself, well, which letters could I part with? Which could I do without? And you can take various approaches to this and look at letter frequency, and there's the classic Eotane Schrödel sort of canonic ordering of frequency. But if your goal is to sort of approximate at least English words and to still be able to sort of approximately cover them, you don't necessarily want to drop letters in strict frequency order. And so I came upon I went through a range of different things in this thought process. So obviously you want a bunch of the high end ones. You want the E's and the T's and the A's and the O's and all of that. Lots of I's and whatnot. But as you get down to a letter like say F, well, if you were willing to sort of do eclectic things in terms of spelling, you might you might do something like say, well, let's use a pH instead, although I hit upon a slightly different solution for that. There's all kinds of, weird history with letters, and you could imagine sort of taking that into account. The letter G is fascinating. For example, it originally was in Roman times. They had had the letter C gradually adopted its current sort of dual role, where it has multiple different sounds, and in some contexts it has a range of soft and hard sounds. And so a particular figure, at least according to Plutarch, came up with the idea of putting a little thingus on the end of it to indicate it, this is a hard G, that sort of thing. You could imagine sort of going, revisiting that decision, as it were. The other sort of quirky one that sort of comes up when you start thinking about, who would I part with in letters? There was once upon a time the long S, and an interesting thing with the long S, it went out right around, shortly after the Declaration of Independence was around the period of time in which it went out. But and a fascinating thing about it, and I've seen a bunch of old editions of, if you get like an old copy of the works of Shakespeare, or there's Byrne has a great copy of Euclid where it still has long S's and whatnot. But one of the many reasons it went out, well, actually, the reason that it existed as a character was to mirror the way Sigma and some of its variants work, but where you have one version of the letter for sort of earlier in the word, and then maybe the small one for the end of the word. But the big problem with it, of course, is it looks like an F. But that's great, right? It looks like an F. If I'm trying to dedupe things, that's another possibility. So anyways, after a bunch of iteration, what I ended up with, I'll put them in the order that I sort of canonically put them on. I ended up keeping C, E, R, and T, and this is sort of in QWERTY order approximately. It's a V and U, of course, right? You can collapse those easily. VIO and P. Oh yeah, another one. There's a fascinating ancient letter in English, a thorn. Now, once upon a time, this made a th sound, but it conveniently also has the characteristic that it looks very much like a P or a B. So and as it happens, P's and B's are relatively infrequent in English, and so. I found on some experimentation that this was an easy substitution to swallow, and then A, S, and D. And so I went with the long S because of its many substitutable things. I ended up keeping G because it in a pinch will make do for Q if you squint a little, perhaps. And then an H, an N, an M, and an L. And there are my 16. And so it's not, a great set, but if you now try this out, a word like fourth, it looks like something, or hello there, SVFIG, fourth interest group. So it's not a great font, but it's not a terrible font. It's and you could imagine with fourth words, you might be dupe, drop, swap, over. You can do push and pop instead of, you don't need punctuation, clearly. And perhaps one thing I hit upon after having actually put in the font was realizing I had originally thought that I would do sort of spelling variations for the K. The letter K is right on the edge of being frequent but useful, but I found that actually in practice, if you wanted to say the word like pick, that an H will do just fine. And so it's a thing. The way that I made the font, years ago, the last time I had done anything with trying to make a true type font, I had used there's an open source package. I now forget the name. That was once upon a time the only one, but there's now actually a rather vibrant set of competing different apps that are online that will let you do this. A thing called Glypher Studio is cute because it requires it is at least I guess in some form open source. And it does not actually require you to keep any data with them, which I found amusing. So you go into the app, and then you can actually just load and save to a local file. And so let's see here. If I go to, I can load up the what I think is the last version of this thing. You can load it up and you can produce a font, and if you go into individual characters, you can just draw Bezier curves, of course, but also rectangles. And so this didn't take a whole lot of time to do. And let me play around with if I liked the shapes. Not sure if I have any particular goal in mind with it, other than again that exercise of doing with less. So, but are there any questions? Why does the Y look like a G? Because I didn't want to blow a letter for the Y. You see, because I didn't want to blow. I have 16 slots. I had to make do with something else. You see yeah. Mm-hmm. Indeed. Indeed. It's an interesting point. Sorry, who?
Chu Mu is a famous letter of fourth dimensions.
Oh.
There was
With the dashes.
3 letters plus count.
Ah. This is the one with the dashes in place of, yeah.
Moore wrote it all wrote his
Yes.
letter in 3 letters plus count and decided Chu Mu.
Indeed. I know the thing of which you speak now. Yeah. So.
Is this yours or? It's just, we don't have a belt clip on it.
Okay. Yeah, Don apologized that he cannot be here this meeting because he's busy stuffing the board. So this is the board he laid out, and he's now working on it. He said, well, it's more important for him to stuff the board than to come to meeting. Okay.
I have a question.
Yes.
Do you know what software he used to produce it?
No. Mm-hmm. Yeah, I think it looks like it's a pretty sophisticated professional.
What's on there besides a processor?
It's going to be have almost everything which controls the robot. Okay, motor drive and sensors. Okay.
How many different motors?
I think 2. Yeah.
So
I think
accelerometers?
That I don't know. I think accelerometer probably he will have a gyroscope. I hope a gyroscope and the sensors. But I really don't know exactly what he has in mind, and he didn't give me schematics either. So he yesterday we met here because he said, well, he's got the flu, so he didn't want to infect you guys with the bug. And I said, well, come over here. I'll cure your flu. So I gave him 1 pound of vitamin C and told him to take a big spoonful, a big teaspoon every 4 hours until the flu's gone. I don't know how. Yeah.
So he mentioned in his email that he wants $35 a piece from people that want a stuffed board, which is, I don't know, pretty damn cheap for how cool this is going to be. If you don't want a stuffed board, just want to throw them a few bucks to support the project, that'd be good too.
Mm-hmm.
Tim, would you be willing to take money to him?
Well, I think you know he's coming next month. So I think you just come to the meeting.
You won't be seeing him before that time.
Perhaps not, but I don't know. I don't know. Yes.
Now, is this going to be ready for Maker Faire by chance?
That's what we're shooting for.
Got a response from them?
Okay. Yeah, we got the booth.
Okay.
We got a booth. Okay. So I think I hope the people who volunteered last time would again volunteer, right? You and 4 computers. Do you still have the computers?
Yes.
Okay. Yeah. Please bring the computers. Yeah, I think the plan is pretty similar to the last time. I asked for 2, 1 10 by 20 feet booth. So we'll set up 4 stations for people to try things, and another table we'll put a projector on it so people can do talks. I think I need 4 people to each one would take care of 1 half-day session. You know, I think it's going to be Saturday morning, Saturday afternoon, Sunday morning, and Sunday afternoon. So I need 4 people to take off these 4 sessions. And I would also like to have people coming and give short talks every hour. You know, we'll have a projector, and you can. I will have a list of topics and the people who's going to be talking. So I hope that we can have a list every hour. Somebody will be there giving short speech on Ford, on anything. Okay. So that's the plan, and then if we have the board stuffed, and if the robots working, we probably will have a few robots running around in the booth. Hopefully controlled remotely, but I think depend upon the network situation. We may not be able to control it very smoothly on the Wi-Fi. But I think Don has his program using his Whisker. It's pretty much self-contained and self-motivated robot that can run around and encounter and deal with all the normal situations. You can block it, you can kick it, and it knows how to respond. I hope that's what he will build. Yes.
Questions?
Yeah.
Do you need me to do machines, prep them like last time, depending upon the situation? And 2, is this new board are they gonna be controlled wireless, or are they just gonna upload them and let them do their thing? Or, I mean, what's the situation between the robot and the machines?
Mm-hmm.
What's gonna be
Yeah, I think just like last time, if you can bring in the computers next month, okay, then I'll have it. I'll bring all the computers to the fair, and I think we'll have these modules around on the table, so hooked up to the USB, so people can doing some forced experiments on the stations. And then we have robots, and the robot, hopefully it can communicate with the computers, and people can actually using the browser to stop the robots. So the robots will be, I hope robots will run autonomously, and anytime you can also send the commands to change its mind, stop it, or so I think the robot will be something that people, I would encourage people to do experiments with, but the experiment will be pretty much limited to send some commands to start or stop. But I think if the Wi-Fi works fine, we will probably ask people to transmit long lines of force code and probably send some colon definitions to the robot. But the least everybody can should be able to do is to get this in up, and we'll have LEDs on it, speakers around the people.
Is that two different stations then? So you've got, obviously probably 4 stations that are going to be hooked up to some boards, right?
Yeah, right.
And then you're going to have another station actually does the Wi-Fi to the robot?
I think the four computers will all be set up to talk on Wi-Fi. And last time we have this router sitting right there, so so all the computers will be logged onto the if they want to talk Wi-Fi, they have to look onto the router. Yeah. It was too busy. Yeah. Yeah. So we have the robots will be running and they'll be controlled from Wi-Fi. But all the boards will talk basically through the USB. Yeah. I think if we have more robots built, we probably will have the robot to turn upside down, so on the people can experiment with the wheels and the sensors. Yeah. I hope that next month we'll have some robot running, and then we can the whisker robot ran quite well as Don demonstrated. So
are the whisker robots that are going to be communicating with Wi-Fi? They're going to be hooked up to access point, right?
Well, I think yes. Yeah. I think we should. The robot would be autonomous. It doesn't have to be attached.
Well, I mean, figuratively.
Yes. It's the
If we can't get the Wi-Fi to work on the laptops, and we have them plugged into the router, which is wireless access, they can still communicate.
I hope. Yeah. I hope. Yeah.
I know we need to talk strategies for a stage thing that we can do. You brought the access point last time. Well, I mean, we need to be able to figure out how to fall back.
Yes.
Yes.
In the
limit will be like nothing works.
Yes.
But I think we need to plan for varying levels.
Yeah. I think definitely we will have 4 of these things sitting around, okay, attached attached to 4 computers on the Wi-Fi, okay. So people can learn force that way. And we will have a couple of robots, at least one robot which can run around, and we can start and stop it. Okay, and if we have more robots, we can take the robot and flip them instead of this little board. We'll just have as many robots attached to the PC through the USB, so people can actually run the turn the motor on and off, turn the LED, turn the speaker on and off. So I think that will be the tutorial or the workbench. Yeah, I think we will invite people to sit around and at least type a few force words. Turn the LED on and off, turn the speakers on and off, turn the motors on and off. And I think Don, of course, was has more confidence in his robot that he want to demonstrate that he can actually reprogram the robot remotely. That I think will be a demonstration only. But if the Wi-Fi network works fine, I think people can actually do that. Okay, and so Don was kind of disappointed that he didn't see anybody signing up for the board, and but we'll see how it worked. I think everybody's waiting to see real things, and I told him all of us are just software guys. People just don't know how to solder, okay? And so that people didn't show much interest until they see things assembled. Okay, so that's the one problem we discussed last night was that Don asked, "How are you going to program this this chip?" I said, "Well, I need USB. Where is the USB port?" Yes, one USB port. It's going to be programmed Wi-Fi, right? Yeah, I think eventually we should be able just to do programming through Wi-Fi. Okay, ideally. Hmm? Right. Yeah, we can kind of check up.
Every time you flash with Arduino or their IDF, it flashes everything. There's no separate bootloader.
Right.
But you're gonna need to get in there somehow.
Yeah. You have to get in. Well, we'll see how it works.
And
okay.
Express does have an OTA solution. I'm not sure it's on Arduino.
No, yes, I remember seeing the OTA, but I have not tried it. Okay, so I think I thought I gave him a board, so he knows what's required of this board. I was just hoping that not doing much hardware. What if I would do it, I would just make the board with the pinout with the sockets, so you can actually just stick this in on board. And this board has all the interface, the motor control and the sensor, everything else. But only with the socket you just plug in. Okay, and yeah, I think this guy is only $3 or $5, so there's no reason not to take advantage of it. But as a hardware engineer, he prefer put everything on a single board. Yes. The soft. I'm thinking software, so I would prefer having something that's working and programmable and stick on the board. I think from the Arduino experiments, if we have an Arduino board, we can take out the CPU chip. Just use the two serial input, serial output pins, and jumper these two pins onto the I/O port on the serial port on this chip. That would allow us to work through the Arduino USB. It's definitely.
Your Arduino chips, you can do that.
Yeah. With a Uno board. With a Uno board. Yeah. Yeah.
I haven't looked at it here yet.
Yeah. I tried it. Yeah. So you see the Uno board has the 80 mega chip, and then it has 2 rows of connectors, and it has a transmit pin and receive pin. And these 2 pins, you remove this the chip, the transmit and receive pins are the serial port, and you can hook it up to anything.
And you'll probably have to have, I think, GPIO2 to put it into bootloader mode. On this guy. On the ESP32.
Yeah. I don't.
Should be able to do it pretty well.
Right. Yeah, we'll see. Yeah, if something's missing, we can jump something up. Okay. Yeah, I think let's just wait to see if Don has his own first robot built, and then we'll figure out how to make more of it. Okay, thank you very much.
Or even if you're not really interested, but have a few bucks to spare, sign up for the board or
yeah.
where?
Yeah.
Well, send them an email.
Yeah, show the support, okay? Show your enthusiasm. That would encourage him to do more faster.
Is there anyone here that's not on the email list? Oh. George?
We went through this already.
Okay.
Be that way.
All right. Okay.
George, how do you feel about
Scripting in? Sure.
about a break now, or would you rather do it later, or what would you like?
I'm delighted with amazing. Look at the clock.
Thank you.
What? Oh, half an hour break? No, half an hour on the table here. Sure is hot here. All right, I will wait till
That's why they're all screaming.
Alrighty. So my name is Sam Falvo. I'm the same old person who does the same old Kestrel project year after year, but every year I always seem to learn something new as I continue on this project. And I'd like to spend probably about a half hour-ish to go over a project that I discovered on the internet called NMyGen or NMyGen, or I'm not entirely sure how it's pronounced, but it's spelled spelled like that, NMIGEN. And there's a link to it on the SVFIG itinerary, which is convenient because that means I don't have to provide one. But basically, I'm still learning how to use this tool, and I'm still just kind of exploring what its capabilities are. High level overview, Verilog sucks. It is literally the assembly language of programmable logic design, or if not assembly language, then it certainly is its COBOL. It is extremely verbose, and you have to write an incredible number of lines of code in order to get your programmable logic to do what you want it to do. In skilled hands, Verilog can probably be condensed down to some reasonable number of lines of code. My S16X4 processor is probably a decent example of implementing a stack-based architecture in about 300 lines of Verilog. Pretty decent, right? But if you want to do something more complex, if you want to build something, say, on the order of, I don't know, a RISC-V processor, for example, Verilog becomes quite burdensome. You end up writing a lot of the same code over and over and over and over and over again, and very little opportunities are built into the language to allow you to abstract that out and factor it and independently verify it and so on and so forth. Which is why the bulk of the activity in the RISC-V community is using a tool called Chisel. You probably heard of this if you're following that community. It is a domain-specific language written in the Scala programming language, which itself runs on the Java virtual machine. Long and short of that technology is it was basically code developed with the RISC-V project at Berkeley University. And it is a higher level, much higher level way of describing hardware. So, for instance, if you wanted to implement, a 5-port or a 25-port crossbar switch, for example, I remember one presentation. I forget if it was Yunsep Lee or if it was Chris Salio at one of the RISC-V workshops. 5 lines of code to implement a 25-port crossbar switch. And that's pretty impressive when you think about it, because all he basically did was say, I need a crossbar switch with this size parameters and this number of ports, and it just spit it out. This tool, NMyGen, is something of the same caliber tool as Chisel. Insofar as that is the case, it is much easier to install and much easier to experiment with and get running. Therefore, lower barrier to entry, in my opinion, than Chisel. And so what I wanted to do was, okay, hypothetically speaking, if I wanted to start building a respin of my KCP 53000 processor, one of the things that I wanted to do was implement new features for it, bring it up to spec with the newer privilege spec, which meant that I needed to implement something on the order of 60 plus new CSRs. That's configuration and status register, kind of like MSR in Intel land. Well, that's an awful lot of friggin' code to write. Even if it is just returning a hardwired 0, I don't want to have to sit there and hand write all that code out. Well, it turns out that with this tool and Migan, I can actually write code which is much more amenable to working with it in my, as a sole developer, and therefore is much more compact. So again, I'm still just exploring it. This is all hypothetical code. This is not actually intended to be live code yet, because there are no bench tests, there's no unit tests or anything like that. I'm still learning how to write the code. But basically, you have a structure, and all of your modules are described in Python classes. They don't need to inherit from anything specific, although in this case I do show an inheritance relationship. If I have time, I'll get into that later. But basically, you have two chunks of code that you have to fill in. And there's that chunk of code there, that init, which defines which signals that you're going to be working with. And then you have this elaborate method. Come on. And the elaborate method is where the magic actually happens. So long and short of it is, the elaborate method is, or I guess you can think of these as macro processors in a sense, because what you're doing, the GEN part of MyGen stands for generator, right? So you're generating Verilog modules pretty much on the fly. And you'll see how this is very convenient. For instance, this mVendor ID through MISA registers, you'll notice that I actually do reuse the same actual class. I instantiate the same actual module class numerous times with optional values here. And unlike Verilog, this happens on a single line of code, right? So this is very compact and therefore much more amenable to working with. Here's another example here, this mHeart ID register. It's a different type of CSR where, like all of these, it's a numerically constant value, but in this case, it actually represents an input, basically a GPIO input in a sense. And I basically take in the value, this connection here, as a parameter. All right, not a big deal. You can pretty much implement something like this using Verilog tasks, I suppose. But what about those 60 plus new CSRs that I needed to implement? How about that? Well, okay. So instead of saying I'm going to define this module and I'm going to list out by hand all these different registers, what I'm going to do instead is, from here to here, here's a list of all the specific registers that are of interest to me. But in this particular block of code, I'm just going to say, you know what? I need 32 constant registers representing my counters, and I need 32 constant registers representing my event handler. That's it. Done. 3 lines of code. I've defined 60 new registers. What I don't yet have, however, is connectivity. For instance, where are the data bus inputs and where are the data bus outputs? How do we handle read and write strobes and all that other stuff, right? And how do we handle address decoding logic? Well, in this particular case, I just route that in this for loop here. I say for register in my complete list of CSRs, I'm going to route the privilege mode and the address from the processor into each of those registers, and then on the output side for indicating whether or not I have a valid CSR or not, I'm basically going to reduce, using a logical OR operator, all of the output valid pins on these CSRs. So basically, my output valid is the logical OR of all 60 plus of these registers. And that is done in one line of code. Well, 4 lines here, but you know, if you have a wide enough monitor, you can do this in 1 line. The only thing that I actually don't have right now is routing the input. So I'm actually going to change that right now. So I'm going to say register. Let's see here. So I'm going to say self.output dat is going to be equal to, basically it would be the logical OR. So this would be the reduction of XY. I'm going to say RO.dat for R in CSRs, but only if it's a valid CSR. So in this case, I would say, and I'm going to replicate O valid 64 times because it's a 64-bit wide word. And just for grins, I'm going to try generating that. And it worked. So now all 64 plus registers that I've defined now have a data output such that whenever I change the address, the output will asynchronously change, depending on whether or not it's a valid CSR. If it's not a valid CSR, the output will be 0 because the logical OR of everything logically ANDed with zeros is going to be 0. Now, let's take a look at that code for grins that it generated. Yeah, I'm just going to hold down the page down key. Right? That's what we're talking about when I say lots of Verilog code. And to be fair, as you can see here, this is all mechanically generated. This can all be hand optimized away and stuff like that. But you're still looking at representing complex logic as you know, sets of assignments. Here's a set of module instantiations, all of which are multi-lines. You know, and basically this goes back and forth. By the way, the bulk of this content is actually these comments here, which are indicating which source file name and line number that min term is generated, so that if you ever have simulation issues, you can trace that back to the original source file. So don't worry so much about that. But, oh, and the other thing is, notice here, it automatically figures out what module ports you need. I mean, you have to help it along a little bit. You have to basically say, okay, I'm interested in some of these ports and stuff. But if it's an input or an output, bus sizes, for example, like all of this stuff is pretty much determined automatically by way of inference. So that's what NMigen produces. And this is basically how relatively quick it allows you to basically route 64-bit buses into a single multiplexer, basically, because that's essentially what this is. This is basically a multiplexer. So where am I with the project, with the Kestrel project, and how does this fit in? Long and short of it is, I'm really impressed with what I'm seeing here. The new processor for the Kestrel 3 will almost certainly be written in NMigen. In fact, I really feel confident that I don't even have to throw this code away, even though this is technically just prototype code. Just today, oops, that's what happens when you switch from VI to Emacs and back and forth. Just today, in fact, during Dr. Ting's presentation, I wrote the implementation for the mStatus CSR. This is kind of a special case because we want the processor to issue an illegal instruction trap if you feed certain fields incorrect data, because it's intended to emulate those particular fields rather than just blindly execute with them. So this gives a slightly better indication of how we do the nuts and bolts programming of individual features. So here, basically, I'm defining the actual interesting ports for that I want to capture and use elsewhere in the chip. And then we have a bunch of registers which we have to define because the spec demands it, but otherwise we don't really do anything with them. Whatever. I have this function here, get unique port lists. Basically, this allows me to accumulate, if you will. This is what allows NMyGen to figure out the interesting ports that that you want to produce in the Verilog code. That's a bit of a mouthful. So then there's this elaborate method, and again, this is where we define the module. These m.d.combs basically is a way of saying, I want to add this to the combinational or combinatorial logic of the description. So basically, I'm saying here that I want output valid to be equal to, and then on this line, I say I want my address to be equal to the constant address. It's a 12-bit comparison. And the CPU's privilege has to be greater than or equal to mStatus, which in this case just, it will always, it can only be equal to it because there's no greater value than that, but whatever. And then I want to make sure that my particular subfield here has valid values in order for this to be considered a valid write. So valid typically is used to indicate, the CSR is properly addressed. But in this case, it's not just that it is properly addressed, but also that the data that you want to write to it, perhaps, is in fact actually a valid data word. And then here I say if the write enable is asserted and we're properly valid, then basically we assign all of our interesting fields as well as our registered garbage. And then for our output, top of the screen, for our output then, we basically concatenate all of these together into a single 64-bit word. And we assign that to our output. And that's pretty much it. It's actually a fairly small definition. But one of the things that you'll notice is it allows me to focus exclusively on what I need to address this mStatus register uniquely. I don't have to worry about anything else. All that other worrying is done down here in the 4R and CSRs and the reduce operations and such like that. Oops, actually. I forgot that. So I will save that. So yeah, so that's pretty much it. I don't have a whole lot of code defined. This is the common CSR module that I wrote. Basically, this has a lot of the reusable components that I have. So we have class CSR, for example. This is just your generic CSR. You'll notice that all it does is it defines all the common signals that a CSR module should have, and that's it. Like there's no elaboration or anything like that. That's why you have to define your own elaborate method. Class CSR select. This actually just focuses on address decoding. So all of these constant CSRs and input CSRs, for example, excuse me, these are used to define numerical constant CSRs, such as hardwired 0, for example. But you'll notice how few lines of code here. But basically, I've got this self-select line. Declares an instance of that select logic, and then here I'm basically saying, here, use this module to elaborate yourself. So I can basically reuse that address decode logic. If there's a bug in this address decode logic, for example, and I need to somehow fix it, like for example, if I accidentally do that, for example, this will work great if you're using it for machine mode registers, but it'll break if you're using user mode CSRs. So if I fix that, that one character fix will fix all the user CSRs, all of them, because we inherit and import and reuse that code so frequently. In Verilog, under certain conditions, you can do something like that, but as a general rule, it's much more difficult. And then again, here's our input CSR. This is interesting because of this call to replicate here. Basically, I'm taking a signal as an input to the constructor here. And of course, I'm reusing the address decoding logic. And basically, I'm padding out to a full 64 bits. So this allows me to pass in a 4-bit value, 8-bit value, 13-bit value if you wanted. Doesn't matter, all the way up to 64 bits. And it guarantees that my output here is the concatenation of the signal and the padding. Now, you may notice that the concatenation is backwards from what you're familiar with in Verilog. That's because it follows Python array notation. So basically, cat starts with bit 0 and counts up. And then, obviously here, this is going to start at wherever the signal left off and continuing to count up. This is backwards from in Verilog, where it starts at your bus width and counts down. So just be aware of that. It's something that is easy to get tripped up over, but once you get used to it, it's actually not that bad. And then if I have, no, that's not what I asked you for. And then in this module, I just have all the common definitions that I use for accessing CSRs and specific subfields of CSRs, for example. And then here I'm defining the symbolic names of specific CSRs. As you can see, there's a lot of them. Most of them hardwired 0. And that is why I was looking into this, is because I really didn't want to have to sit there and hand tweak, 128 registers. And then, of course, there's the MISA register bits and flags, some convenient functions to access them. Definition of how to interpret the implementation ID CSR, and of course, registers to manipulate those. I'm sorry, functions to manipulate those. And yeah, that's pretty much it that I've got defined so far. You've seen that it does synthesize, well, it doesn't, I don't want to say synthesize, it compiles to Verilog just fine. Oh, this is probably, so if I do a word count on everything that is in Python, we see that a grand total of 570 lines and grand total of about 12 and a half kilobytes worth of source code. If we do the Verilog code, it's an order of magnitude larger because of all the definitions, and more than an order of magnitude larger in terms of byte code. And again, the Verilog is mechanically generated, so it's not going to be the same as a handwritten Verilog. But that is an indicator of if you're doing this by hand in Verilog, it's going to be bigger and it's going to be more complex and it's going to involve more accounting. Yeah. So where am I going from here? So now that I have an understanding of how to produce output from NMigen, my next step is to figure out the best way to use formal verification with it, because I've had extremely good luck with formal verification and actually getting it to produce error or defect-free code, and then start synthesizing. Yes.
Are you still planning on working with the RISC-V processor?
So the question is, am I still working with RISC-V? Yes. The KCB 53000 is what is running the Kestrel 2DX. The 53000B, which you probably saw at the header of that right there. The 53000B is basically a bug-fixed version of the previous processor. Instructions will run a little bit faster, on average, shaving 1 to 2 cycles off each. Most instructions will now run in 3 cycles, versus an average of 3 to 5 or 3 to 7 before. Again, wait states not counting, notwithstanding. But the other thing is there's other bug fixes as well, mostly in the CSRs, which is why I wanted to focus on this. It'll have a proper user mode now. It's not just machine mode anymore. It'll actually have machine and user modes. The instruction set architecture register, the MISA register, will, I had a bug in that one in the previous build. That's been fixed, and the implementation ID register will be updated so that you can actually tell one CPU from the other, if you're so interested. So yeah, a lot of new features coming down the line without substantially changing the architecture. Yeah, the RISC-V architecture is starting to stabilize. The privilege instruction set still not. I don't know how close to a 2.0 spec that they are, where 2.0 is really 1.0 because reasons. Yeah, but basically they're at 1.10 right now, and the differences from 1.8 to 1.9 to 1.10 have been getting smaller and smaller and smaller with each revision. So. Like I said, the only significant change from my 53000 to the 53000B has been basically bug fixes and just adding the new CSRs that I'm obligated to implement because of the new standard. But for the most part, it's exactly identical. The 53000B and I predict the 53010 that will follow up after this. Is almost certainly going to be drop-in replacement compatible with the 53000. So basically just swap out the source code. What's that? No code changes. Not unless you depend on reserved fields. Because if you depend on reserved fields, then all bets are off. But if you stick with the public interface, then no code changes are needed. Cool. Any other questions? Then I think the best remedy for what we're going up next will be to enjoy our apple pie. Oh, but first,
a couple of quick distractions before that. I wanted to cite pi. So those of us that know a few digits, let's start off with 3.14. Anybody know? Next. 3.14159 53589. 9, 7, 9. Okay, that's enough.
My grandnephew who lives in the North Bay, he knows a lot of it. Not everyone, but he knows a hell of a lot.
Kevin, I've heard that within pi, every conceivable string is in there someplace. So I can recite, say, encoding this into ASCII characters. I can tell you that within pi is the phrase Buddy Sorrell. Buddy Sorrell. When Alan Brady wanted a tribute to him just to show Buddy Sorrell was the first to defend. It was a takeoff on the unfinished symphony. But it's got to be on YouTube. The Dick Van Dyke Show, Carl Reiner, Alan Brady, Chorale.
So how many of you read Saturday morning breakfast cereal? How many of you have heard of Saturday morning breakfast cereal? Okay, what a relief. So the robot's going to bed. It's trying to kill us. Wait, I have an idea. Robot, calculate pi. Done.
But
What? But it's infinite.
yeah.
Oh, sure, but it can be stated as an infinite sum or product. I'll explain while I dismember you. In 1655, the great John Wallace was thinking about sine waves, ... This sucks, says the woman. So, what do we learn for this? We learn it's time for a break.
Sorry to keep you from ice cream, but I remember one of a project I did, a programming project on an HP 87 calculator, you know, had a little memory stick. Anybody remember those? And basically the programming was you would enter numbers that would be the row and column of the button you wanted to have push. Okay. And so I thought of an interesting problem to program, which is actually relevant to fourth. So we all know that in grade school we used 22 divided by 7 to be a representation of pi. And later on we learned that 355 divided by 113 was a little bit better one. So the question is, you know, what's the next one? What are two integers such that one divided by the other will give you the closest approximation to pi or any other irrational number? So I did this on this little calculator and tried to see how far it went, and basically I ran out of battery power. But I think I have the next 3 or 5, and you can use that in // to give you your pi multiplication. So it actually is practical, and you can do that with e or square root of 2, square root of 3. But you know, you got to start out, you know, comparing it to the best representation of pi you can have, you know, in the system that you're working on. And so I did this in BASIC, and I did it in TCL, TCL.
Alpha tags.
Yeah. So the algorithm is, you know, you start with, for pi, you start with the numerator being 3 and denominator being 1. And then you see if that's above or below pi. If it's below pi, you increase the numerator, do that test again. And if it's above pi, you increase the denominator, and you just keep on going, and you do the division and compare with pi and see if that's the best match you've had so far. So that's algorithm pretty easy. But it requires a programming system that can do, you know, these kinds of divisions.
But I would guess that someplace along the line, the limitation would be in BASIC or TCL to perform an accurate division of that. But it's just an interesting thing to do.
It'd be interesting to run that on Python or Scheme, which support big numbers.
Oh, okay. Okay. I also recall a few years ago on Pi Day, there was a skywriting plane that wrote pi to, I forgot how many digits it was, above Stanford.
I was gonna say, I think I remember seeing
Yeah,
bits of that.
I was on campus and I saw that, but it was toward the end and things were sort of disintegrating.
Yeah.
Okay, on to Pi Day, the dessert.
Ready to go?
All right. Glad to hear it. Okay. All I get on the video is a spinner right now. Oh, Wi-Fi is off for some reason. That's what I get for wandering around with my phone on my hip. I have to accept the terms and conditions. There are all these, you're familiar with this thing called CC&R, Contracts, Covenants, and Restrictions, when you buy a house? A lot of them have been, here, sign this. Okay, it says I won't have any goats and I won't sell to anybody that's black. Okay, goats, I'm okay with. The black thing, you got a problem. You'll probably be thrown in prison for signing it now. It says it's connected, but it doesn't seem to be. All right, I feel like we've accomplished. All right, sound check is over. We are back to the meeting, Dave. All right, so I wanted to tell those of you that weren't here that there's a whole pile of JFARs that just escaped your possession because others have grabbed them. If you have fourth books that you don't want anymore, give us a call or an email or something, and we'll discuss. Maybe we'll pay the shipping costs and you can send it to us. Oh, there's the Jupiter. Is that the new reprint of the Jupiter Ace? It's available on Amazon. The Jupiter Ace fourth programming book. Isn't that a hoot? These days, you probably at the next vintage computer fair there'll be, or festival, which is it? There'll be reproduction Jupiter Ace devices for powered by Arduino. Yeah. There's a project to make a reproduction IBM antique computer. It's the IBM something or other Junior. All right, so we have one little more piece of. Hey, John! You don't have to pay attention, but you do have to stop talking. Ting! Ting! If you got to talk, go outside, both of you. I was saying, my wife asked me why I had this. And I was saying, it's for bludgeoning those that aren't paying attention. Class! So Tig was asking how much they cost. I want to say it's $9 and change, so $10 for the 4000K version. That's the sort of white one, and $13 for the 6500K Kelvin, if you wish, version. By the way, those of you that are saying degrees Kelvin, you're wrong. All right, I wanted to say we did have one more little piece of fourth-oriented content, and like I said, you've escaped the actual physical paper versions, but Leon and Fourth Incorporated have provided you with this archive of the Journal of Fourth Application and Research. And if you can't find it with all that I've just said, Send me an email so I can mock you. Or help you, one or the other. The problem is I get to decide which. So I sent out an exciting email notice that the agenda was on, it wasn't the usual format, so it might have escaped your notice, but the agenda was up a day late and $1 short, and not even reflecting my usual level of care and concern, but we digress. So, how many of you have a woman to tell us about? Because it's Women's Month. Anybody? Okay, good. What a relief. I have a couple. All right. I'm going to skip through these pretty damn quick because I didn't want to write down a lot of material, giving you the idea that I was going to tell you everything there is to know about these people, but there are two things that you want to do. Wikipedia is your friend. A lot of these people have Wikipedia. If they don't, they should have. And the other thing is that there are books involved. So, the American Revolution, we don't usually think of women being involved. I suggest you have a look out in the world because there's interesting material in that regard. Mary Walker, speaking of wars, on her breast, you note the Medal of Honor. There's only one award that has that name. It's not called other things. That's what it's called. She won it. There were, I guess, in the past, some jerks that said, no, she shouldn't have that. And they rescinded it. It was later restored, but just the fact of its being rescinded was a disgrace. How many of you have heard of Minnie Pearl? She could make people laugh. She was really good at it. She's one of the people represented by a bronze statue in the lobby of the Grand Ole Opry. Later in life, she demonstrated that she was a person of remarkable intelligence and heart. And she was the spokeswoman for a cancer center and a philanthropist. And like it says there, several hospitals, cancer center, and the Sarah Cannon Research Institute are named in her honor. I became aware of this woman in this particularly obnoxious round of California ballot propositions. She was doing one of the little soundbite in opposition to one of the particularly onerous ones, really obnoxious thing. But anyway, she wrote this book about the Second Surgical Hospital and about her experiences in Vietnam. And I recommend the book. And so, anybody recognize that thing behind the illustration of Margaret Hamilton? Anybody? It's the Apollo computer, yes. And we've talked about that in the relatively recent past, but she led the software project that got us to the moon, the onboard software on the Apollo spacecraft. And I recommend you acquaint yourself with her role and activities. Everybody know who Larry Nassar is? Good. His name should be forgotten, except among whatever vile circle of hell he winds up in. But it took quite a while for anybody to speak out because this was a particular group of young women that had a goal to compete on the Olympic national stage in gymnastics, and they felt that if they spoke up, they would lose that opportunity. But it had to start somewhere. So how many of you have been to the Legion of Honor Palace of Doom, or whatever it's called? Okay, there's some hands. We have Big Alma Spreckles, in large part, to thank for that. Okay, now, how many of you remember this slide from the past? Okay, good. What a relief. Oh, wow. All right. So if you need to be told about Amazing Grace, you're in the wrong room. So Edith Clark was an engineer in a time when women weren't engineers. And it wasn't any of this feminist crap. It wasn't any of the, I'm lesser, so I should have special consideration. It was do good work. We're in the old slides part of the presentation. If you remember these, great. If not, well, you weren't paying attention last time. Colonel Kim Campbell, she's my hero. You know about spread spectrum and you know about frequency hopping. You carry it on your hip or wherever you carry your phone. You have Hedy Lamarr to thank for it. She invented it.
There was a great program last night. They had a PBS program about her life. It was very interesting.
Was it a Nova or other?
Other.
Okay. So a lot of the PBS programs are available on the web or otherwise. I know I'll be looking for that myself because it sounds interesting. Thalidomide. Why didn't we have thalidomide problems in this country except for a bare handful of cases?
Birth defects.
Yeah, it was given to pregnant women without proper testing beforehand, thinking, oh, it won't penetrate the barrier in the placenta. And it turned out they were wrong, and it was a big drug company, and they put a lot of pressure on the American folks that were in charge of food and drugs. And it was largely responsible for a new generation of rules and laws in that regard. And we were able to escape large numbers of problems, large numbers of birth defects caused by that drug because of this woman. And it's a long story, and I recommend you learn about it because it's interesting stuff, and it's something that should be taught in school. So let's get into the who women in fourth. And if you have women in fourth that you'd like to tell us about, send me an email. We'll have them in Women's Month next year. But the first slide should really be remarkable people who were women, but Elizabeth rather remarkable contribution to Fourth and Fourth Incorporated, and much to be thanked for. And Thea Martin was on the board of FIG International and the editor of a bibliography of forced references. I think I have a citation in there. Rochester FIG chapter directed the Institute for Fourth Research, and one of the handful of FIGI award recipients. And I see more books in the back of the room. You actually have the platter?
I'd have to find it again, but I have one.
Was there only one, or did everybody get one?
Everybody got one.
Ting, do you still have one?
Figgy.
A figgy, the platter? Oh, okay. Maybe we should have a bring your figgy to work day.
There's only two.
Two's enough.
Okay.
Two's more than enough. Two's twice as many. We have redundancy. Don't get me started. I could do an hour easily on designing for redundancy. A bad idea if you don't know what the hell you're doing. You'll introduce more failure modes than you'll solve. All right. What else we got? Oh, I might play this if we have a minute at the end, but suffice to say that there was a college bowl. Anybody recall what I'm talking about? Where they'd ask questions and teams from two colleges would compete, and Princeton was there, and they were a bunch of doofuses and, you know, clean cut, nicely dressed. I guess they spent the preparation time drinking and joking around. Oh, these women can't know much. We'll beat the crap out of them. It turns out that that they lost, and in a way that makes me feel good about the way they lost. And let's see if we can click this and see what happens. Something might happen, who knows? I get a spinner, of course, that's great. So, well, yeah, it's an older version of Microsoft Office operating under Windows 7, which is about as new a version of Windows as I could manage to stomach. So, I re-registered at the start of this. Oh, this is painful. Now, let's see, do we have enough juice to get to the audio? No, we don't. Of course not, that would be too easy. So we're gonna have to get some plumbing for the audio part of this video. While we're doing this, does anybody have any additional stuff that they'd like to talk about?
Now they're also going to what's called multi-boot, which means I can put a whole bunch of Linux distribution, whatever distribution I want on this thumb drive.
Yeah, but that's what your product is. It's just this without anybody having to put it together for you with some other utilities and stuff put on it so that you could actually do your work if you're like a civilian. This thing is to make a computer. It's not a repair device. It is read your files. I'm telling you what this product will do. I don't have one on me. Yeah, it's.
All that's saying is you can access the hard drive only if the hard drive is functioning.
That's true, but if you have an old computer with an old version of Windows and you want to use it like for your kids to read their email or some damn thing, this will do it. The product that he's talking about, that's what it is. It's Linux and a few utilities like a word processor, open office kind of thing, and some other stuff to make an actual working PC that's not bogged down by some old crappy copy of Windows. And if your hard drive doesn't have a working copy of Windows, you can still boot your computer. But that's the extent of its repair capability. It's not a diagnostic or repair tool. What? But if you don't know enough to put Linux on a stick, or you don't have a working computer to do it on,
Even buying the stick is
Processing so that I can
because you can't really unless you buy buy a cheap USB stick.
Nowadays, please enter.
I can still use GDB to debug whatever it is I want. And I can do it on a Raspberry Pi if I wanted. And let me go to that Raspberry Pi to programmable
Yeah.
have other USB boards that have the faster USB, because I mean USB 4.0 is 20 gigabit, no, 40 gigabits, but they use two 20 gigabit lanes. Oh, it's
Not physically possible. By the way, I wanted to say that I realized why that Wi-Fi enabled flash drive was so inexpensive. It was the 16 gigabyte version, and they make larger versions. So I wouldn't buy the 16 gigabyte one. That's hardly enough space for a copy of DOS. So these are the women from Agnes Scott that beat the Princeton boys at Quiz Bowl or College Bowl. So you can look it up. I won't show the video because I'd like to adjourn. But if you have any problem locating it, send me an email and I'll give you a link. And I'll try to restrain myself from snarky comments. And I think that concludes our.
In 2016, Taiwan elect its first woman president. Okay, and she was kind of a fan of Hillary. Was hoping that Hillary would get elected as well, but eventually Donald Trump gets elected. But the U.S. policies, foreign policy, China has been dominating the U.S. policy. So the Taiwanese never have a direct channel to the U.S. government. But Donald Trump told the Taiwanese that he would accept a congratulation call from this woman president, President Tsai. Oh, everybody's getting scared. So finally, she made the call, and Donald Trump answered the call, and they have a couple of minutes of pleasant talk. But the Chinese getting hopping mad. but it's the first woman president in Taiwan. But lately she's got in trouble because she was convicted of corruption. No, not her. She's okay. But then earlier, that was South Korea. South Korea. But in Taiwan, she's okay. But the economy is going sour. So in the last election, the mayor election, she just lost out of the 22 seats. She lost 15 of them, and she's up to election next year. And the chances that she will be elected is very slim. So she may be the first president in Taiwan which doesn't get to be elected again.
I'm going to turn this off now. So good night. Yeah. Goodbye. That was it. I'm going to turn this off now. That was goodbye. That's. All right. This concludes this meeting of the Silicon Valley Fourth Interest Group. We'll hope you'll join us next month in April. In May, there'll either be a very special FIG meeting or they'll be with a very special top secret program chair, or we'll have Maker Faire activities instead.